Using normal distribution. This is one of those topics that I really enjoy teaching, so I hope you enjoy this lesson as well. Your state standards are listed. Here are your success criteria. Find probabilities in normal distributions, be able to interpret normal distributions, and find probabilities in standard normal distributions. Vocab. Normal distribution is one type of probability distribution. The graph of a normal distribution is a bell-shaped curve called a normal curve that is symmetric about the mean. This is the important part of the definition here. It is symmetric about the mean. A normal curve, a bell-shaped curve that is symmetric about the mean. Next, we have the empirical rule. The percentages of the area lie within 1, 2, and 3 standard deviations of the mean are given by the empirical rule, or the 68, 95, and 99.7 rule. About 68% of the area lies within 1 standard deviation of the mean. About 95% of the area lies within 2 standard deviations of the mean, and about 99.7% of the area lies within 3 standard deviations of the mean. Anything else, that extra 0.3% would be just considered outliers. But here's a nice visual graph of this. So you can see that, remember, this is the mu symbol. The lowercase mu symbol means average. And in your calculator, average is X with a bar on top. But there's 2 different symbols that mean average, means the same thing. But you're going to see this anytime we're using things from the book. You can see the 68% here is between negative 1 standard deviation and plus 1 standard deviation of the mean. And then the 95%, you can see that's within 2 standard deviations of the mean, either below the average or 2 standard deviations above the average. And then, of course, the 99.7%, that falls within 3 standard deviations above and below the mean. So that is a normal bell curve. Standard normal distribution is the normal distribution with a mean of 0 and a standard deviation of 1. All right, so your z-score, this is the formula for your z-score. So you can see your z-score takes the x, just a normal x value, minus the mean, divided by the standard deviation. And that will give you your z-score. It'll tell you where it falls in this distribution set. If it's close to the mean, it's going to be 0 because the mean falls right in the center. Okay? The z-score for a particular x value is called the z-score for the x value and is the number of standard deviations the x value lies above or below the mean. And again, you see if going to the left, it's a negative z-score, and if you go to the right, it's a positive z-score. But this is still within 1 standard deviation of the mean below the average, and this is 1 standard deviation of the mean above the average. So that's kind of how you interpret the z-score. This right here is just your bell curve broken down. On the EOC, they will give you the 68, 95, and 99.7. What you can do is break these down further so you have smaller percentages. So if you're answering questions, it makes it easy. So they'll give you these. Hopefully this is easy to memorize. But 68, half of 68 is 34. So you know each side of this is 34 and 34. And then again, if you break down these smaller pieces, you can see out here is the 0.15. Here's 2.35% in this area. And then right here is 13.5. And this is 34. And if you look, because this is symmetric, these numbers will match the numbers on this side as well. So let's see what we can do to use this information. Example 1, finding a normal probability. A normal distribution has a mean and a standard deviation. An x value is randomly selected from the distribution. Find the probability that the x falls between negative 2 standard deviations and the mean. All right, so this is minus 2 standard deviations of the mean, and this is the mean. So again, we're going to use our normal distribution curve. We can use the 68, 95, and 99.7. Let's go ahead and use the other table. Let me pull that up. All right, so I copied this normal distribution curve over. Instead of getting the 68, the 95, and the 99.71, I got the one that's broken down a little bit more, because if you see, we're going from the mean minus 2 standard deviations up to the mean. So here's the mean minus 2 standard deviations right here, and here's the mean. So basically we want to find this area that is between right here. All right, let me see if I can highlight that area. So this is the part of the normal distribution curve that we're looking at. So we're going to do everything between the mean minus 2 standard deviations up to the mean. All right, so that's just two different ways to look at it. First, I drew the arrow here from the mean minus 2 standard deviations up to the mean. So what we would need to do is find those percentages. All right, so we know that we've got 13.5 and 34. So we can just add those numbers together. So 34 plus 13.5, and that's going to be about 47.5. So we can say that the probability that a randomly selected X will fall in this highlighted area is about 47.5% of the time. All right, so I want to reiterate how important it is to know these symbols and to study your vocabulary, because as you can tell, this is a very easy problem if you know what this right here is asking you and you know where to look to find your answer. Example 2, interpreting normal distribution data. The scores for a state's peace officer standards and training test are normally distributed with a mean of 55 and a standard deviation of 12. The test scores range from 0 to 100. About what percent of people taking the test have scores between 43 and 67? An agency in the state will only hire applicants with test scores of 67 or greater. About what percent of people have test scores that make them eligible to be hired by the agency? All right, so let's just think about A part first. What percent of people taking the test have scores between 43 and 67? So the first thing we have to do is look at what we're given. We're given a mean of 55. So we know that the mean goes in the center of your bell curve. So that means 55 goes right here. And then it says there is a standard deviation of 12. So 55 plus 12 would be one standard deviation above it. Plus 12 again would be two standard deviations, and so on. So 55 plus 12 is 67. Let's see if I can write these numbers in here. I'm going to write this one sideways. 67 is one standard deviation. 67 plus 12 is 79, so that's two standard deviations. And 79 plus 12 is 91. All right, so that's my three standard deviations above the mean. Now, to find my standard deviations below the mean, I have to do the same thing, but I have to subtract the standard deviation from the mean. So what's 55 minus 12? So that would be 43. I can't write a 3. Give me just a second. All right, and 43 minus 12 would be 31. And then 31 minus 12 would be 19. So this fills out our entire normal distribution curve, starting with the mean in the center, all right, and then adding 12 each time to get the standard deviations to the right. You subtract 12 each time to get the standard deviations to the left. Now it should be easy if you remember your percentages. So it says about what percent of people taking the test have a score between 43 and 67. So if I take my highlighter here, here's 43 up through 67. So of course it includes this whole area right here, but that's plus and minus 1 standard deviation from the mean. So we can quickly determine, if you remember your 68, 95, and 99.7 called the empirical rule, you know that 68% of the data falls within that middle part of the data. So let's see here. Let's write 68% is A part. All right, now we're going to do the same thing, except we're going to look at B part. So let me erase that highlight. All right, B part says an agency in the state will only hire applicants with test scores of 67 or greater. So here is 67, and greater would be everything above 67. So it's this whole percent here. And then, of course, can't highlight that out through there without running over the lines, but you get the idea. So it says about what percent of people have test scores that make them eligible to be hired by the agency. All right, so if we know everything below 0 would be 50%, and we know this accounts for 34%, so 50 and 34 is 84. So basically you're going to say 100 minus 84, 100, because the whole entire data set, everything in the normal distribution curve accounts for 99.7 plus the outliers. So you're always talking about 100% of your data minus, again, you know this part is 50%. And you know this part is 34%. So we know the part that's not highlighted is 84%. So it's easy to see that there's about 16% of the people would be hired. So it says what percent of people test would be hired. So if it's greater than 67, this part right here would be about 16%. So that would be B part.